Okay, I've got a a precision rectifier circuit I built, it's full wave, and it's based on the 1458 op amp, which is basically a dual 741. But I wanted to show you the ramifications of that. Um, this is the circuit, that I have rigged up. That's the waveform I'm applying to it, powering it off this power supply. Um, plus or minus 9 volts. Um, and here, is the waveform from analog discovery I'm applying to it. Not that waveform, but this one down here. So, you can see it's, got like a 2 volts or so. And that's the resultant waveform right there. Now let me stop it for a minute so you can see what the baseline is. Alright, so that's the baseline. It's right at center 0. So yeah, you can see that pretty much it's working. There are these little dips though. Like you can see there, it's actually dipping negative by about 20 or ish millivolts. Yeah, 20 or 30 millivolts maybe. No, maybe, 10 or 15 millivolts, something like that. So this one, doesn't quite get down to 0. It's at, somewhere around 40 millivolts. Let me expand the time base here. Oops. Okay, so we'll get a better look at it. Yeah, it's about about 50 millivolts above 0 there, and maybe 20 or 30 below 0 there. So so there's a little bit of an offset there, and it really works out to around 30 millivolts or so of an offset voltage. So now the whole point of a precision rectifier like this is not to amplify 2-volt signals like you see here. It's to be able to get below 0.65 volts, which is the limit of most rectifiers. Alright, that's why you use a thing like this. Otherwise, who cares, right? Power supplies and stuff, you wouldn't need to use it typically. Now, let me go ahead and, so let's get down in the range, of what we're wanting to see, something below 0.6 volts. So let me, try to keep track of the peak to peak there. That second one for channel 2, that's what this is. So we're getting down to 1.6, 1.4 volts, 1.1, 0.9, 0.5, 400 millivolts. Now we're definitely below most diodes. 200 millivolts, we're below pretty much every diode. At this point, I need to expand the range. 100 millivolts. And of course, there's a fuck up a lot of noise here and everything. It's again because of my rig up. There's lots of noise floating around here, including from this lamp and just all kinds of stuff. But that actually is kind of beneficial a little bit. I do kind of like seeing what kind of noise, the effect noise has on some of this stuff. But yeah, we're certainly starting to see some, effects here. But let me go ahead and go down to like 100 millivolts. And let me expand this range up to like 50 millivolts. Okay. Now let's go down even further to 50 millivolt signal and expand the scope again. Okay, now you're starting to see the interesting effect. Um, damn, this thing's jitter. Where's the damn cursor at? I don't know where the stupid cursor is. This is too jittery. What is it? Oh, there it is. Okay, let's get it up here. Alright, let me change this a little bit. Okay, now you're really clearly seeing the effect here. You know, we're at you know, 70 or 80 millivolts signal level as far as this thing can determine. Let me stop the scope. Okay, so you know, basically that's 142 millivolts. Or I'm sorry, it's 40.8 millivolts, something in that range, 46 millivolts. And this other one's only 12 millivolts. And you can see this signal here is certainly going negative by 14 millivolts. So, and over here it's even a little worse, 20 millivolts or so. But again, this is a great example of what having an input offset voltage does to you. You know, basically that's what we're seeing. Even at the larger signals, you can see about a 30 millivolt difference in the peaks. Even when we're talking about being like 4 or 5 volts, you know, you can kind of measure that. But that's coming from the op amps themselves, the 741 analogs. And like I said, those can easily have, you know, 10 or 15 millivolts, depending on your device. And here we got 2 of them in the same circuit. You know, as you can see here, you know, we got two 741s basically. So yeah, both of these could be contributing error, especially if they're sympathetic with each other, and they probably are here. So that certainly could account for 30 millivolts or so of offset voltage. And you know, since these are dual 741s, they're not adjustable. There's no offset adjustment. So, but it does show you, you know, firsthand what op amps, you know, and the input offset voltage, how critical it can be. Now, like I said, we can continue. Let me run this again. You know, we can continue to diminish the input signal. Let me go down to 20 millivolts. And like I said, with this much noise, you know, I mean, it's, you know, hell, that other peak's practically disappeared. It's really not even operating like a full wave rectifier anymore. So, you know, because that's our input signal, but you can see it's pretty damn noisy. But yeah, it's barely operating like a rectifier anymore. Sometimes you can see peaks and sometimes you can't. In fact, earlier it was actually still operating at this level, but as a rectifier, but you know, but I guess it's warmed up now or something like that. So it's, you know, again, it's drifted off base even worse. So, you know, at the end of the day, you know, because offset voltage a lot of times, you know, is temperature dependent, so you'll have drift. And so anyway, that's why it's a good idea to be able to deal with offset voltage, especially in things like this. Now, you know, hypothetically, and you know, a circuit like this, you might be able to get it down to as little as 100 microvolts or something like that if you didn't have all this noise and shit and everything were adjusted properly, because it's really just a function of the open loop gain, and the higher the open loop gain, the lower the level you can go down to. But you know, still 100 microvolts is kind of wishful thinking for an op amp like this. But I'm saying that might be like the very lower limit, you know. But certainly around 1 millivolt it should be fine. And we're throwing, you know, 20 millivolts peak, peak at it. So you know, you'd think you could pull off a better output, but you know. But with that offset voltage and the other, you know, issues of a, you know, the 741, you know, you can only go so far. So But at any rate, that just goes to show you how important it is to use a halfway decent op amp and or have compensation capabilities built into your circuit. Because otherwise, yeah, you do get uneven peaks, to say the very least. When you get down to the signal levels you may be interested in. Like right now, we're at 85 millivolts, so peak, and you can see it's telling us 130, 120 or 130 millivolts peak to peak. So whereas it actually should kind of match up with 85 millivolts under the circumstances because we are rectifying it. But you can see there's certainly drift below our zero baseline too, because remember zero is right over here, so I mean it's going like 40 millivolts below. As you can see on this baseline here. So anyway, it's just an interesting learning opportunity. So anyway, cheers.